Hey there, Science 20. Welcome back. I thought we would just kind of get right into our next lesson video. This is on vector diagrams. Now, when we talk about vectors, remember, vectors have a direction. So using a line, just an ordinary line to represent uh, movement or direction, it's not enough. We need to have an arrow to help show us a direction with it. So um, let's just kind of talk about how we're going to use these vector diagrams. So a few rules to keep in mind. Number one, draw with a straight edge. Now, I am going to do my best to draw with straight edges on this, but unfortunately, not necessarily the best uh, thing to do with the technology. Like I could probably draw a fairly straight line this way, but even with a straight edge or a ruler, it's going to be a little bit harder to get that line. But you guys don't have an excuse. You should be using rulers, and if you need to borrow one, I'd be more than happy to help you with that. Next rule: the arrow needs to point in the direction of motion of the object. So if an object is moving from this point here to the right, that's the way that the arrow should be pointed. If something is moving in a north direction, typically we would draw north with the arrow straight up. South would be straight down, etc. Draw to scale would be our next rule here. In other words, uh, try to use at least a proper proportion when compared to other vectors within the same diagram. So down here you see this is 10 meters moving in this direction. This is 6 meters moving in the same direction. You need to show that the um, 10-meter direction or the 10-meter displacement is going to be longer than the arrow for the 6-meter displacement. And usually if you use in a ruler, rule of thumb would be something like keep it the same. So like if I was doing this with a ruler, I'd probably use my ruler and say 1 centimeter equals 1 meter. So I would draw a 10-centimeter line for the 10 meters and a 6-centimeter line for the 6 meters. Should be not too bad. Um, we need to have a number either written on or beside the arrow. Uh, so again, we put it like right up here, 10 meters right on top. You might want to have it maybe beside, so you could put the 10 meters like this. But I find with arrows, it's usually best to do it this way. Up here, this might be like 7 meters, etc. But yeah, anyway, so that's what we're doing here. Now, because the arrow is indicating the direction, we do not have to have a positive or negative sign written with the numerical value because the arrow is showing the direction. So again, here we're saying 10 meters pointing to the right, 6 meters pointing to the right. Let's look at this example down here. There's a couple issues with this example, and I'm just going to try to uh, I'm just going to give you a few moments, see if you can figure out what's wrong with this bottom arrow down here. Take a moment, just pause the video. Yeah, pause it. If you're looking for stuff, there's actually two problems, I would say, with this. Have you figured that out? Okay, well, first of all, negative sign. Yes, it's going in the opposite direction of these two arrows. Absolutely. However, because we can see by the way that the arrows are pointing, this is irrelevant. Absolutely irrelevant. We don't need to say that this is a negative 6 meters. If we were writing this as we're doing this plus this plus this, and we're doing the formula, it'd be 10 meters plus 6 meters plus minus 6 meters. That's where we would put the negative in. But here, we know it's going the opposite direction. We know that because it's going the opposite direction, it'll have a negative symbol up here. So that's going to be uh, useless to have. The other issue is look at how long this arrow is. This arrow is almost as long as these top two arrows are combined with each other. And yet we say that this is a distance of 6 meters. Well, if we want to be drawing this to scale, it should be the same length as this arrow, more or less, and definitely not longer than the 10-meter arrow. So the better way to draw this would be having the arrow point this way and then just putting 6 meters, no plus, no minus, just 6 meters. That would be the right way to draw this arrow. This is absolutely the wrong way to draw it. Okay, now, one of the nice things about doing vector arrows is that we can actually use them to help us solve some of the questions that we're going to be dealing with. So we can combine multiple arrows to come up with a full vector diagram. Now, here's what we need to do. First of all, make sure that the vector arrows are always added by placing the arrows tip to tail. So the tip of the first arrow should be right next to the tail of the next arrow. So in this example here, we see that something is traveling 10 meters in this direction, 6 meters in the same direction, turns around and moves 8 meters back in this direction. So this a vector diagram is really good at helping us tell the difference between a distance traveled and a displacement. Now remember, distance is just how many meters or what the total distance that is traveled by the object or the individual. So this would simply be 10 meters plus 6 meters plus 8 meters. And that's going to equal 24 meters. Now, displacement is going to include the, and I should say that is like the change in distance. The change in position or the displacement is going to be a little bit different. So we're going to start here. We're going to move 10 meters to the right. So when we move to the right, we're going to say it's a positive 10 meters. And by the way, it might always be helpful to just show that if we have just something like this, where we show that if we move in this direction, we're moving in a positive place. If we're moving the opposite way, that would be negative. Anyways, our next arrow is going to be an additional 6 meters. And then our third arrow is 8 meters, but because we're moving in the opposite direction, we're going to be putting a negative sign in here. So we move 10 meters, move another 6 meters, that's a total of 16, move 8 meters back the other direction, and that will put us at 8 meters. However, don't forget, we need to use the plus sign to show that we are, the displacement is going to be 8 meters from our starting point, which is right here. Now, if you've drawn your arrows to scale, you should see that the first arrow plus the second arrow is going to equal about half, or is going to be double those two together, double the 8 meters, because you should be able to have another 8-meter arrow going from the tip of this to the tail of the last one. So again, if we're using the 1 centimeter equals 1 meter, this would be a total of 10 centimeters. The second arrow would be another 6 centimeters. And then we move 8 centimeters back that way. If you measure from here to here, we would see that this would be another 8 meters. So because we're 8 meters from the starting point right here, we would say that that is our positive 8 meters. Okay. So let's look at a couple practice problems together, and then you can do some homework to just give you that extra practice. So Tommy walks 7 meters north, turns around, walks 50 meters south. Well, what is the distance he's traveled? Well, that's pretty easy. 70 meters plus 50 meters equals 120 meters. Excellent. The displacement. So, and again, you're going to have to forgive me because I don't have, I mean, I'm going to try my best with this, but on the device that I'm using, it's not always going to work out the nicest. But basically, we're going to go 70 meters up this way. Actually, that's not too bad. Okay, so this is 70 meters. And then he's going to turn around and he's going to come 50 centimeters this way. And again, I'm not actually using a ruler. I'm just using a straight edge that I had available to me. So that's just going to be the 50 meters moving south. So the end, the final position that we're in, is I go from the tip of the first arrow, or the tail of the first arrow, to the tip of the second arrow, and I would draw it this way. So what I'm drawing in blue is going to be our answer here. So since we're going in a north direction, we could say that this is 20 meters north, or positive 20 meters. If you include the direction, we don't need a positive or negative. If we don't include the direction, positive or negative is going to be necessary. Okay, let's do this one. So again, we've got a situation where a man is going to walk east 275 meters. Let me grab my straight edge here. Now, obviously, I'm not going to be doing 1 centimeter per 1 meter, because that would mean I'd need almost 3 meters plus just to draw this first line here. But if I were to draw it this way, I guess I'm going to be using blue for this diagram. This is going to be our 275 meters going east. Why am I not putting a plus sign there? Well, remember, we know that this is going to be, we know that the direction, so we don't need a plus or a minus sign with it. Now, the man then turns around and he's going to travel. See, this is where the straight edge isn't helping me out too much. But we're going to go this way, and we're going to be traveling 425 meters west. So that would be our vector arrow diagram. Now, how do we find the distance? Well, the distance traveled, the change in distance, is simply going to be 275 meters plus 425 meters. That is going to give us a grand total of 700 meters. No plus or minus, no direct. Basically, if he had a pedometer and he was tracking how far he moved, he would move a total of 700 meters. Now, keep in mind that when we are looking at the displacement of the man, we need to establish and remember that east will be the positive direction and west would be the negative direction. So then how do we find the displacement? And remember, we got to put that little half arrow above it. Well, now we're going to use plus and minus signs. And because going west is the opposite direction of east, and that's moving in a negative direction, we're going to go 425 meters, but we got to put that negative sign in there. So now when we add these together in your calculator, you're going to end up with negative 150 meters. Now we could leave it like that, or we could say it's 150 meters to the west. But we're never going to say negative 150 meters west, because the negative sign indicates that it is west. So we're just going to not do that ever. That is a big no-no. Right. So I want you to try this one. Take a moment, give it a shot, see how it goes. So pause the video. When you're done, unpause, and let's see how you did on it. I'm going to assume that you have unpaused the video. If you didn't pause the video, I'm very disappointed in you. Please note, you should be doing this the right way around. Anyways, okay. So let's take a look here. Here we're looking for the displacement. Now, I could draw the diagram. Now let's keep in mind that when we're doing a displacement, north in this case is the positive, and south is the negative direction. So we're saying that April is going to walk 5 meters north. I really should be using a straight edge for this. My apologies. 5 meters north, turning around, and then walking 2 meters south. So to find the displacement, and again, got to put that arrow above, to find that displacement, positive 5 meters plus negative 2 meters equals positive 3 meters. And let's not forget sig digs here. Because we're adding and subtracting, we take the fewest number of decimal places as we can. They're the same in both, but please put in the 3.0. Don't put in a 3 and just leave it at that. It should be 3.0 for compensating for the correct number of significant digits. Now, again, we could do it this way, or we could say it's 3 meters to the north. The total distance is going to be our 5 meters plus 2 meters, meaning that April has traveled a grand total of 7 meters. Okay, she's ending up 3 meters away from where she started. Okay, 3 meters away from where she started. All right. Last one, I'm giving you, showing you the work here, but let's just take a look at it, make sure we understand what's going on here. So Joe's driving 10 kilometers east. He stops, turns around, goes 50 kilometers west. He stops and goes 5 kilometers east again. So since he's driving, we can track on the odometer how many kilometers he's traveled. So his odometer would go up 45 kilometers. So your odometer on your car is only going to calculate the change in distance, the amount of distance that you've traveled. A displacement would be different. And again, we've got west being the negative direction, east being the positive direction. So we're going to start here. Doesn't matter where you put it on. Just put a start here. Going to start here and go 10 kilometers this way. Boom. That's the plus 10 kilometers. We're then going to turn around and go 30 kilometers west. So that's going to be adding a negative 30. We're then going to go 5 kilometers east again. So we're going to add another positive 5 kilometers. So we go positive 10 plus negative 30 plus positive 5. Put that all in your calculator. You'll get negative 15 kilometers or 15 kilometers west. All right. So that's everything that I have for you in this lesson video. So please take a moment, go through the questions that are here in the textbook, these example problems and practice problems. And if you run into any trouble with any of them, just let me know, send me an email or ask me in class the next day. And I'll see you guys in the next video.